Hello, my dear students. Welcome to Byjus exam prep. Hope you guys are fine. I'm audible. I'm visible, guys. Am I audible? Am I visible? YouTuber ji, namaste. Hello. Okay, guys. So today we'll be starting regarding the new series, as you guys know, that is the startup series, in which we'll be starting environmental engineering from the basics. That is, we'll be starting from the water demand topic. So, guys, let's be quick. Let's be quick. Good evening, Arun. Good evening, Raghavendra. Good evening, everybody. Okay. So, guys, first share the session as fast as you can so that we can start the session. I'm good, Arun. Okay. So, let me see. Okay. So, let's start the session, I guess. Why to wait more? Okay. So, guys, I guess you know that this series has started so that we can start the topic from the scratch in case you are new and you're preparing for Gate 24. Okay, so let's start the session. But before that, if you are new to our channel, then do subscribe the channel. And if you don't know about me, you can go through my profile. Next, coming further is, let me tell you, okay, this was a workshop today already. So you can obviously see the recorded version of it also. If you're preparing for GATE 2024, what are the points you must know? So this workshop already I've taken it, but you can see the recorded. Okay, no voice. Am I audible now? Let me check it out. Guys, I am audible? I guess I'm audible. Rishabh, Arun, just check it once. I guess I'm audible because I've checked it. Okay, fine. So, yeah, you can go through this. Apart from this, if you want to know when my sessions will be coming and my shorts, my daily dose, you can join my Telegram group for the same. And last but not the least, GATE preparation ebook link is in the description. It is free of cost. You can join it. Okay. And now as far as possible, we'll keep the session short and crisp. We will not extend the session, but we'll be talking about all the important things which is to be covered. So why do wait? Let's start. Okay. So before talking about raw water, we have to talk before talking about water demand. Okay. Now, basically, actually, when we talk about water demand, it comes on the topic of raw water engineering. Actually, the whole fundamental, like if you will be doing your major project or minor project, and ever if you go in any treatment units, you will see that basically the whole process starts from the source. I'll take a white pen. It starts from the source. That means from the source you will extract water, okay, and you will go for treatment units and then the process in which you supply it to the community. So the process by which water is transported from the source to the community, the whole engineering involved in this comes under raw water engineering. Comes under raw water engineering. Then you will say, ma'am, what about the wastewater engineering? The all the raw water or the water which is converted into waste because we use it for drinking, cooking, washing, and etc. etc. So the water when it converts into a wastewater, then after applying the engineering, basically purifying it and doing all those things, then it is transported back to the source. So this is the arrow is this side, and here the arrow is this side. Okay, so this comes under wastewater engineering. This comes under wastewater engineering. So the source to community, right now won't be talking about wastewater engineering. Firstly, we'll start from the basics. So first we will be talking about the engineering where water from the source is transported to the community. Now, we also call it as raw water engineering or simply water engineering. So basically, what do you mean by raw water? Raw water is that sample or that water which is collected from natural source. Basically, there is no human intervention or there is no man-made things which is done. That is raw water. So you are collecting that water directly from the natural source. That comes under raw water. Now, actually, the whole thing that, ma'am, we want to know the whole concept. the whole diagram. That means from the source where it will go, then how will it get purified, and then how it will reach to the community. So I'll tell you this whole diagram is there. First of all, we select a source. Obviously, for selecting source also there are bullet points. You have to select such a source where water is available for 365 days. It should be not like in rainy season you have abundant amount of water, while in summers you don't have water. We can't use that source, and we can't be dependent also on that source. Okay, so we have to select that source accordingly. Now what happens after this? We, with the help of pipes, take that water to the canals or pumps. Okay, then again this water is taken to water treatment plant. There, depending upon the testing, okay, depending upon the testing how the water is, we do its treatment. Okay, after that the water which you have seen it in your locality, that pani ka tanki which you have it, that we call it as service reservoir, or you call it as water tank also. So in that, the water from the treatment unit is gone through that service reservoir, and from that service reservoir the water is distributed to your homes. So this entire process, right from the source to the place where water is given to you, that means distributed in your community, this entire things comes under raw water engineering. But now the question comes, when I'm talking about the source, how can I select the source? That is also a point of concern. You are saying that we will treat the water, we will supply it in the service reservoir, we'll distribute it to the people. But the main major question comes into action. How will you determine the source? How can you know that which source is useful for you, which source will be able to fulfill your requirements? And that is the reason we have to study the topic water demand. So before starting any topic, you should know that why there is a need for starting the topic. Got it? That means before deciding the source, I want to know the needs of the people. I want to know what is the demands of the people. Got it? Now the question comes, how will I know the demands of the people? Is there some criteria? Is there some range? Or is there some limits? Yeah, we'll check it out. So, before knowing what is the demands of people, we have few terminologies which we have to do. But before that, I'll tell you the sequence. First, you will know what is the demand of people. So, you will know what is the water demand. The moment you came to know what is the water demand, you will check the quality of that water. Obviously, if harmful substances are present, can you supply it? No. So, first, you will check the quality of water. So, after this, you will be checking the quality of water. After you have checked the quality of water, you will be doing treatment of that water. And now you will say, ma'am, if water does not have any impurities, very fit, do we have to do treatment? No. Simply do disinfection and supply it. But you know, that rarely happens because we are talking about Indian subcontinent. So it just rarely happens. So we'll be talking about quality of water. After that, we will give the treatment of water. After that, we have pipes and pumps and all those things. With the help of it, we will have service reservoir. So this entire process comes under raw water engineering. So actually then we have distribution. We have various types of pipes laid. We have various types of systems like dead end system, grid iron system. If you don't know, don't worry. We'll be starting in the later classes. So we have the whole system designing, that is distribution system. In the some pipe pumps and all those things also I'm including. So distribution system. So all this comes under the topic of raw water engineering. That's why when you see the syllabus, this comes under raw water engineering. This comes under raw water engineering. Now comes further. Now, if you have doubt in any point, you guys can comment. I'll answer to the points which I have discussed and you're having doubt. The ones which I haven't discussed, don't ask that because other people will get confused. Okay. Now, coming further, we have terminologies like I told you how to know what is the demand of water. We should have some unit. Like if suppose I'm inviting, like Arun said that a party is there in his home. So obviously, if he'll invite 4 people, so he'll be like, okay, fine, I'll cook 1.5 kg of rice, and I'll cook 1 kg of dal. So he has that unit. That means he is measuring the quantity of the food in units. That means in kg. Similarly, if I ask about the demands of the people, I need to have a unit for it. So here the unit is LPCD. How it came? Let's talk about it. In the case of water demand, you can call it as demand also, you can call it as draft also. Okay. Now talking about annual draft, or you call it as annual demand. There is no hard and fast rule for denotion, but generally we denote it by capital V. Now, what do you mean by annual draft? Annual draft means how much quantity of water is required by a certain set of people, or you can say by a group of population, or you can say by a community in the entire year. That means 365 days. So, volume of water required in 365 days for a particular community. So, I'll write it down: annual draft, volume of water required by community or by population in a year, or you can say in 365 days. That comes under annual draft. Okay. Now talking about annual average daily draft, or you can call it as annual average daily demand. This is the quantity of water which is required by that population P only, but for one day. Now see, for 365 days, P population for 365 days require V quantity of water. So that same population, P population, for one day will require how much amount of water? Simply unitary method, V by 365. So annual average daily draft means volume of water required by that community in one day. Okay, so on an average basis, that's why the term annual average daily demand is written. Now coming further, annual average per capita daily demand. This word per capita, sometimes in books you will find they have written per person, and sometimes you will see they write it as per head. All the meaning is same. So I'll write the synonyms also: per head, per person. Okay, so annual average per capita daily demand means that population requires how much amount of water per day. That comes under annual average per capita daily demand. Now see, if we talk about V was what? Total water requirement for the entire city in 1 year. Okay, so this was in liters. When we divided it by population, you will get for per person. When you divide it by 365 days, you will get for one day. So per capita consumption, or you can say annual average per capita daily demand, means one person one day requires how much quantity of water. So it's like one person one day requires how much quantity of water. So they require this much quantity of water. Now, if you talk about the units, like I said, now if we talk about party and all those things, like Arun became so excited, he's ready for party. So actually, when you talk about this total yearly water requirement by per person, you report it in terms of LPCD. Okay, LPCD. This is the short form and this is the official one. So it's not because of out of laziness I have created this short form. This is the official one. The meaning of it, I'll write it down: liters per capita per day. So if I say that my consumption is 200 LPCD, that means per day I require how much water? 200 liters of water. This is the meaning of it. So when you talk about water demand, LPCD stands for per person per day requires how much quantity of water. This is the meaning of it. Okay. Now talking further, we have types of water demand. Generally, you will say, ma'am, why do we need to study all these things? Why do we need to study the types of water demand? The reason for it is, guys, as I told you, this whole schematic flowchart diagram, you will see that you have to design the water treatment plant. You see that water tank in your homes nearby to your locality, they have to be designed. The pipes need to be designed. So for how much quantity of water they have to be designed? So we should have a design, okay? We should have a parameter for which we are designing it. And that is the reason we will check it out, that how much amount of water is required on an average for domestic basis, for industrial basis. All these things we'll be checking it out. Okay. Now, talking further. So domestic water demand, actually, if I talk in detail, we have a further bifurcation, that is LIG, low income group, and HIG, high income group. And we talk about full flushing system. Okay, we are not talking about conservancy system and all those things. We are talking about full flushing system. Now you will say, ma'am, why this discrimination? So guys, why to tell means, I guess you also know that, like, when you talk about high income group, they will be having a big lawns, they will be having 2 3 cars, they will be having a swimming pool, they will be having a bathtub. So that's but obvious that the water requirement will increase for sure. Okay, so there is a slight bifurcation. The impact is basically on the domestic water demand. If you talk about low income group and high income group, other things remains the same. Okay, so now when you talk about domestic water demand, its variation is round about to 135 lpcd to 225 lpcd. Industrial water demand, its the variation is 50 to 450 lpcd. Now you'll be like, ma'am, such a vast range, why is it so? 135 and 225 is almost near about, but 50 and 450 has a vast difference. Why? Because obviously you know that small scale industries are there, large scale industries are there. So that is the reason this range will depend upon the extent of industrialization. It also depends upon which industries you are. Yes, rubber industry, paint industry, paper industry. So based on that also the water requirement varies, the water demand varies. Then you have institutional water demand, commercial water demand, like you have schools, you have hospitals. So all these places also obviously water is required. So generally it is 20 to 50 lpcd. If you want to go in very detail, like you will say, ma'am, in hospital beds are there, so per bed requires how much amount of water. If you have that much of query, so we have codal provisions. Okay, we have Government of India manual. So in that you will be getting everything, so don't worry, I'll show. Below the link I'll try to post that link so that you can download the code. So if you are having any query like what will be the water demand and all those things, so that will be clear in depth. However, it is not required, but if you have that curiosity, we'll do it. Okay, now talking about water for public uses, like you know that cleaning of roads and public paths and all those things also require water. So it requires 10 to 20 lpcd of water. Now talking about further fire demand, technically you have to include this also. So basically you know that that is not prevalent, means everyday fire does not break ups in your city, but still you have to have some quantity of water saved for fire demand. Okay, so generally it is very less, 1 lpcd, that means 1 liters per person per day. Based on that you have to save the water. That's it. Okay, that's it. Now talking about further, fire demand, how to calculate, we have various formulas related to it. These are empirical formulas. Many students might already be knowing the meaning of empirical formulas, while if you don't know, let me tell you, empirical formulas are observation based. Let us suppose a scientist has studied n number of papers, research papers, and then he developed that formula. So it's very much strict that what that scientist would have told to substitute the units, you have to substitute that unit only. Okay, otherwise you won't get the correct answer for sure. So that's why along with remembering the formula, you also have to remember that in which unit you have to substitute it. Okay, so now the various formulas are, first is Kuchling's formula, that is 3182 root p. Let me tell you, here the population is not the normal population, here the population is in thousands. So example, if the population is 4 lakhs, so here you won't be substituting 4 lakhs. Okay, here you will be substituting in terms of thousands, that means 400. You would have seen it also generally in foreign, how much is your salary, we say 400 thousands, they never say 4 lakhs, generally they say 400 thousands. Okay, so this is the meaning of saying, and here also it means this only. So if you are talking about population in thousands, so you have, instead of substituting 4 lakhs, you have to substitute 4 lakhs. 400. Okay, now talking about Freeman's formula. Now this formula has a very, you can say, ambiguity. In different books you find differently. So let me tell you, the formula for Freeman's is 1136 p by 10 plus 10. Okay, here some books you find p by 5. So generally when it is 1135.5, then we use p by 5 plus 10. However, this is a matter of discussion, but generally in books you will see whenever there is 1135.5, you use p by 5 plus 10. Otherwise, when you take a rounded of 1136, we take p by 10. Okay. Then you have National Board of Underwriters formula. In one of the state level, this was asked that where do we use, up to which population we use. So let me tell you, this National Board of Underwriters formula, we use it up to a population of 2 lakhs only. Ma'am, if population is greater than 2 lakhs, which is practically possible, then National Board of Underwriters formula have given different provision. So otherwise, 4637 root P 1 minus 0.0401 root P is the formula. If population is greater than 2 lakhs, then directly they have given you, if it is larger, you have to have 54,600 liters per minute, plus in case if a fire is there and second fire breaks up, then in case you have to have an additional provision of 9100 liters per minute to 36,400 liters per minute. Okay. Last formula is Buston's formula 5663 root P, where P is again population is thousands. Let me tell you, in all the 4 formulas, Cushing's formula, Freeman's formula, National Board of Underwriters formula, or Buston's formula, in all of these 4 formulas, you have population P in thousands. Okay, and there's one more, and which is very important. Let me tell you one thing. This fire demand formula, if see, generally we have the habit of reading books, and when you go to library, some things which have colder provisions, be it in RCC or be it in anywhere, I'll advise you that kindly check the edition. Reason why I'm telling you is, many a books till now write fire demand as 97 root P. But let me tell you, this was prior to 2012. So if you see a book before 2012, you will be tend to seeing this 97 root P. Then you will come to me that, ma'am, I have studied 97 root P. How are you writing 100 root P? So let me tell you, it has been updated. Now as per IS code, you will be having 100 root P. But everywhere else, you were substituting the population in thousands, and the discharge which you were getting was in liters per minute, because this is an empirical equation. But here, in this 100 root P, obviously here also you will be substituting population in thousands, but here the amount of water for extinguishing the fire, or the demand for fire, this will be in kiloliters. So this you should know. Okay, in every of the 4 formulas, everywhere population was in thousands, the discharge was in liters per minute. But here, what will be happening? You will be getting the demand in kiloliters. Got this? Okay. So these are the formulas. Don't worry, in the question they will short mention you which formula to use. So you don't have to worry, bam, there are n number of formulas, which formula to use, it will be clearly mentioned to you. Okay? Okay, fine. Any doubts still here, guys? Any doubts still here? Anybody? Do let me know. Okay. You told us the demands. Okay, you told us the demands. Okay, there's one more demand. If anybody knows, like, kindly tell me losses and thefts. Can tell me how much is the percentage? Losses and thefts. Losses and thefts. Technically, it is not a demand, but if you are not including this, then what will happen? Then what will be happening? Your designing will fail. Example. And you will say that somebody thieves water. So yes, they do. In places where there is scanty of rainfall, or where there is no supply of water, or very less water is there people tend to steal the water also. You won't believe, but it happens. Okay, sometimes leakages and all take place. Okay, so now let us suppose I supplied 200 liters of water. Okay, 200 liters of water. And the demand was also 200 liters. So we supplied 200 liters and the demand was also 200 liters. Now what happens, due to any reason leakage took place and 20 liters of water was lost. So now what is the water reaching to that particular person is 180 liters. So is the demand fulfilled? No. So that is the failure of yours. Why? Because he needed 200 liters. You supplied 200 liters, but because of the loss, now he is getting how much? 180 liters. So if you want that his demand should be fulfilled, you need to supply 220 liters, so that if 20 liters go wastage, then also he should get 200 liters. So you incorporated additional 20 liters for fulfilling the demands. So that is the reason losses and thefts are technically not a demand, but you have to include it. Otherwise, it will be the failure of raw water scheme. Okay. Now, Liter, no, no, it is in kiloliters. Iron Man, it is in kiloliters. If you add all of this, generally the range is 220, 250 to 350 LPCD. If nothing is given, we go for the designing of 335 LPCD. So if you add all this, 15%, yeah, generally we take around 15% and all. Okay, 10 to 20% we take the variation, losses and thefts also. Okay, so this is the that means per person per day requires almost 335 LPCD of water. The range is around about to 250 to 350 LPCD. Now you will say, ma'am, is it mandatory that a person needs 335 liters of water? Now what to say? If you guys, no, we take it as 335 LPCD. If I talk about a high income group, if I talk about Chandra Kishore, okay, generally we take it as 335 LPCD. Okay, the range I was telling, see, it can be on the upper limit, it can be on the lower limit for sure. Okay, depending upon the low income group, the high income group, and all those conditions. Got it? Total 270 you are saying? No, total we take 335 LPCD. Okay, generally if nothing is given, we take it, I just took a broader range 250 to 350, but the prominent we take is 335 LPCD, because here range is given to you, na, 135 to 225, 50 to 450, 20 to 50, 10 to 20. Okay, so that is the reason. Any doubts still here, guys? Good evening, Sriram, Meena ji. Any doubts still here? Anybody? Clear, Chandra Krishore? Okay then, let's start further. Now, ma'am, you told us that unit is liters per capita per day. Per person requires how much amount of water, but we need to design the pumps, the canals, the water treatment units. So that is the reason we have a few terminologies. First is MDD. That means maximum daily demand. This is an official form. That is official means MDD. You can see it in the papers and all also. It's not that I have created a short form. This is the official short form. Now, when you talk about MDD, that means maximum daily demand. It means to say that out of the 365 days, there will be a day when the demand of water will be maximum. So that is known as maximum daily demand. Now, this, what the expression I'll be telling you, this is observation based. What is that expression? 1.8 times annual average daily demand. And I told you what is annual average daily demand. That particular population P requires how much amount of water in a single day. Okay, that is known as what? That is known as maximum daily demand. Got this? Just a minute, guys. Hold on. Okay, am I visible? There's a slight problem in the connection. Just wait. Okay, guys. Actually, few slides ka I guess kuch something has happened. So no issues. Am I visible? Board is visible. That's more than enough. Is it visible? That's important. Is it visible, guys? Just tell me in the comment section so that we can start. Board is clear, no? That's important. That's important. Okay. So now when you talk about maximum daily demand, so no issues there. When you talk about maximum daily demand, that means out of the 365 days, there will be a day when the demand of water will be maximum. So that comes under maximum daily demand. Okay, and annual average demand, I already told you that particular population requires how much amount of water in one day. Now in the question, generally they don't give you this annual average daily demand directly. They will give you the population is P. Okay, they will give you some population value and they will give you per person requires how much amount of water. Example, if you see that they have given the population as 2 lakhs and let us suppose per person requires 300 water, 300 LPCD of water. Okay, so annual average daily draft will be 2 lakhs into 300 LPCD. So this will become how much? 3 2s are 6, 2, 4, 5, 6, 7. So this will be 60 into 10 raised to power 6 liters per day, which will make how much? It will make 60 MLD. Million liters. You know the meaning of million because we are watching YouTube. So 1 million is 10 lakhs. So this is 60 MLD. So generally they don't give you directly. They write it in this format. So this is maximum daily demand. Now talking about maximum hourly demand. Generally, first I will tell you the wrong misconception which everybody have. They think that maximum hourly demand means that the entire 24 hours in 365. That means in 365 days there will be an hour when the demand of water will be maximum. That is known as maximum hourly demand, which is a wrong concept. Maximum hourly demand, whenever you will read handbooks and whenever you will read some books also, they just write only maximum hourly demand, which is wrong. Actually it is maximum hourly demand of maximum day. That means, example, let us take it as tomorrow was what? Tomorrow was 1st May. Okay, so let us suppose on 1st May the demand of water was maximum. Now that was known as maximum daily demand. Now on this 1st May, there will be an hour when the demand of water will be maximum. So that's why maximum hourly demand of maximum day. This comes out to be 1.5 times annual average hourly demand. Now, if you want to calculate annual average hourly demand, 1 hour demand, 2nd hour demand, 3rd hour demand. So, of the 1st May, every hour demand, when you will add it, what you will get? You will get maximum daily demand. But you need average hourly demand. So, this demand was for 24 hours. You need it for 1 hour. Average. So, you will divide it by 24. Okay. Now maximum daily demand will be how much? 1.5, 1.8 into, let me take, I'll take the full form only. Annual average daily demand divided by 24. So this will come out to be how much? 2.7 into annual average hourly demand. Okay. So you can take in any manner you want. Any doubt in this? So annual average hourly demand of maximum. Hourly demand of maximum. Got this? Got this, guys? So this is the basic funda which you should know. And one more equation, because based on this equation, if you're preparing for your state level examination has been asked, and this is the Goodrich equation. This is the P is equal to 180 T to the power minus 0.1, where T has to be greater than equal to 1 day, first of all, and P is the percentage fluctuation. What do we mean by percentage fluctuation? I'll tell you. If you substitute t is equal to 1, you will get it as 180 percentage. Fluctuation means how much the value, average value is, basically maximum value is more than the average or minimum value is less than the average. This is the meaning of percentage fluctuation. So if you talk percentage fluctuation, you will say it here, maximum daily demand divided by average daily demand. Similarly, if you want this type of questions, 4 options, which are the option is correct, they have asked already. When you substitute t is equal to 7 in this equation, remember this formula is valid only when t is greater than or equal to 1 day. So when you take 7 days and you substitute it here, what you will get? 187 to the power minus 0.1. So maximum weekly demand divided by average weekly demand. This will come out to be how much? It will come out to be round about 148%. Similarly, you can substitute t is equal to 30 days. Maximum monthly demand to average monthly demand. Substitute it. How much you will get? Round about 128%. You can do it for yearly also, substitute 365 days. So can I say one thing, that as the sample size increases, the percentage fluctuation decreases. See, initially 1 day was the sample size, then 7 days, then 30 days. So as the sample size increases, the percentage fluctuation, or you can say the deviation, decreases. Okay, this is the meaning of it. Okay. So now guys, this was the whole diagram which I've already told you. We have already studied about maximum daily demand. Out of the 365 days, there will be a day when the demand of water will be maximum. That was maximum daily demand. Out of that one day, there will be an hour when the demand of water will be maximum, which you call it as maximum hourly demand. There is a term which you don't know, so which has been asked in many times examination, coincident draft. So let me tell you, coincident draft is maximum daily demand plus fire demand. Fire demand, don't worry, they'll tell you which formula to use for calculating it. So sometimes they ask you coincident draft. So technically they're asking you to calculate MDD plus fire demand. Okay. Now, as I was telling that we have to design canals, we have to design water treatment plant, we have to design service reservoir. So this is the whole table, you can say, which you have to basically study. Remember it for some of the examinations also. Generally don't not that much important as far as gate is concerned, but now since NAT is there, they can ask you in statement wise. MSQ is there, so they can ask you in statement wise. Shriram, I'll take your doubt at the last, or you can mail me, or you can message me in Telegram also, no issues. Okay. When you talk about source, the design life is 50 years. We design it for maximum daily demand, pipes, pumps, canals, everything is written to you. I'll tell you the one, why we are designing source for such a long number of years. So let me tell you, the whole equipment, the whole system is dependent only on source. So if you will not design it for source, what will happen? So obviously the source has to be designed for a maximum number of hours. Years basically, not hours. If you talk about pumps and canals, I have just written Q because generally you would have seen it at your homes also. Do you operate the pump 24 hours? Because you know that you have to on the pump so that the water can store in your tank, which you have it in your home. But do we operate it for 24 hours? Of course not. We operate it for an hour, for half an hour. So similarly here also we don't operate it for the complete number of hours. Okay, so that is the reason Q. I have just written discharge because in the question it will be mentioned for how many hours we are designing the pumps and canals. Talking about service reservoir, actually we'll be studying in the upcoming classes in detail. Service reservoir, we have balancing storage, breakdown storage and fire storage. Okay, so that is the reason right now I'm not discussing that because that is a topic. So we don't design it for MDD or MSD. We have a different theory for that. Okay, remaining coming to the distribution system and all, we design it for either coincident draft or maximum hourly demand. Okay, whichever is maximum. 99% time maximum demand plus fire demand comes out to be maximum. but doesn't mean that you won't calculate it, because you don't know how the equation is framed. It might be possible that you tend to make mistake. So that is the reason, do check it out, MHD also and MDD plus fire demand. Now I'll tell you a few things. In some of the exams they write it as MDD, fire demand, MHD, and none of, and this is A option, B option, C option, and D option is maximum, or you can say A plus B. They write it like this. Okay. So in this type of questions, you will take mark only D option. Okay. But in some examinations, what they do, they write MDD plus fire demand. Then they write MHD. Then C will be maximum of A and B, and D will be none of this. So in such questions, you will mark C. So actually in various examinations, they tend to differ the options. That is the reason, on the basis of that, we have to choose the correct options. Okay, so it depends accordingly. Fine. So I have told you a lot. Now let's solve a question. Let's solve a question, guys. Be fast. Let's solve a question. Finally, we have to solve one question. So here I have to tell you the capacity of distribution system. So whenever they ask you capacity, what you have to do is, first you have to calculate MDD, MHD and fire demand. So guys, here the population is given to us as 2 lakhs, 2 into 10 raised to power 5. Per person demand is 300 LPCD. So the total demand comes out to be how much? Total demand comes out to be how much? We'll take it out maximum daily demand. This will be 1.8. Per person requires 300 liters. So 2 lakh people will require how much? Come on guys, how much it is coming? Just check out the calculation once. You will call it as 108 MLD. Okay. Now we have to calculate fire demand also. Fire demand we'll go by Buston's formula because it is mentioned in the question. This comes out to be formula you have to remember. For best remembering the formula, practice 2-3 questions of that particular topic. The formula will be done. Population in thousands. So here you won't be substituting 2 lakhs. You will be substituting 200. Okay. From here you will get the answer in liters per minute. How much you are getting? In liters per unit you will be getting 5663 80086.91. So you have to convert it into what? You will convert it into million liters. So just multiply by 24 into 60. It will be converted into liters per day. Liters per day. I'll just take it as 155.32 into 10 raised to power 6 liters per day. So this will become 115.32 million liters per day. Okay. So if they ask you coincident draft, this will be how much? MDD plus fire demand. So this will make how much? 115.32 plus 108. This will come out to be, I have multiplied it by mistake, plus. This will come out to be how much? Coming out to be how much, guys, for you guys? 223.32. So this is the coincident draft. If I talk about MHD, MHD will be how much? 1.5 times of MDD. So 1.5 times of MDD. MDD maximum daily demand is how much? 108. This will make 162 MLD. So we have to take the maximum of MDD plus fire demand and MHD. See, I told you, 99% of the time MDD plus fire demand comes out to be maximum. How much it was? This is 162 and this was 223.32. So we get that we will design it for 223.32. Okay. This is the answer. Okay, I just want to ask, do you want to get a question for your homework? A good question which I know that many of you will have problem in solving. Do you want that? If you want, I'll give it. Fast. Yes or no? Do you want that homework? Okay. So this is a homework question. Don't worry, if you are not able to solve, do tell me so that in the next class I'll be dealing that question. So you guys can take a screenshot, or otherwise the video will be available for you live. Okay. So this is the question. I've dealt this question, but you don't Google it. Okay. No, you don't have to see anywhere else. You have to apply your brain and solve it. Okay. National Board of Underwriters formula I already told you, but here there's one thing which is written. This will change the whole problem. So that's the reason. Okay. And guys, today we have done with the class. Tomorrow, not we won't be having class. This class is TTS, Tuesday, Thursday, Saturday. So on Thursday, that is on 4th of May, I'll be talking about alkalinity right from the scratch, all the things, like approximately, I guess it will be a 1 hour of class, because I'll be telling you all the 5 cases. P is greater than M by 2, less than, P is equal to M, all the things accordingly, the whole experiment. So once you attend that class, you don't have to see any other books for the procedure, nothing like that. So obviously the class will be at 9:30 p.m. Where this is gone. So the class will be at 9:30 p.m. on Thursday also. Okay, link is already being created, so you guys can click on that link in case you have any queries or anything else. Okay, you have set that reminder, and you can tell me the answer in the comment section. And if you have problem, do write, ma'am, please deal it in the next session. If you'll tell me that, so I'll include that slide. Otherwise, I'll assume that everybody knows the answer. Okay, and if you don't, do comment it so that I'll check it before coming to the next class on Thursday. Okay, so that's all for today, guys. Take care of yourself, and thank you for being here. Like the splashed came out, it was the bursting of the lights, but then also for being there with me. Thank you so much, everybody. Take care of yourself. Bye bye, good night, and steady heart.